Hello everyone, I am Professor Sreenath, Associate Professor, Department of ISC, NMIT, Bengaluru. So today I will be discussing about box plot, a visualization technique which we follow in exploratory data analysis. So before going into details, first let us know what is box plot, why box plot, and how to construct a box plot, and then followed by example where we can construct a box plot and we try to interpret and analyze box plot. So firstly, box plot is also called as box and whisker plot, which is a file summary data. So we make use of file summary data and then plot our box plot. Okay, and basically it used to show the skewness in your data and also to find out if any outliers are there in the given data set. Okay, so this is how we can visualize a box plot. Like we have a minimum value which is present in your sample data set, the maximum value which you can see here, and in between you can see a box which consists of Q1, Q2, which is also called as median, and then Q3. So basically we divide the given sample data set which is of interval scale into these partitions so that we can find out the skewness and also we can see if any outliers are present in the given data set. So this straight line is called as whiskers. Okay, this is whiskers, and this is what our box, and that's the reason why it is called as whisker box plot. That's why it's called box and whisker plot. Moving ahead, why this box plot? Like as I told you, basically we can make use of this box and whisker plot, or in short box plot, to represent or to explore basically in exploratory data analysis, which represents information from a file number summary. So I'll tell you detail about how to calculate this file summary data. So given this scale interval, okay, which we can find the shape of the distribution, that is whether it is a normal distribution, whether your data points are left skewed or right skewed. So that's what we can know, and apart from that, as I told you, we can find out if any outliers are there. Yeah, that's the same thing I discussed in the points here. Now in this box plot, we are supposed to find out Q1, Q2, Q3, max, min, and taking these values, we are going to plot our box plot. So let us see the step-by-step ways to construct a box plot. So any given data points, the first step is we have to order the given data points. Okay, so given any random data points, first we need to arrange it. That's the first step. And second step is we have to find the median. I'll just show you how to find median. So we have a formula for that where we can find the median, and median is also called as Q2. And third step is find the quartiles. So quartiles like Q1, Q2, Q3 and Q4. In the next slide, I'll show you how to calculate these quartiles along with median. And next step is once we find all these 5 values, that is min, max, Q1, Q2, Q3, then we can plot our box plot. So next step is step by step. We have to first label, take a scale, okay, and in such a way that we can sufficiently plot all the data points. And given that scale, what we are supposed to is we have to mark Q1, Q2 and Q3. That steps I'll just show you next slide. So we have to mark Q1, Q2 and Q3 values above the number line. And next step is we have to draw the vertical lines from number line to those 3 points. Okay, and next step is we have to draw the horizontal lines from outside box, okay, to till the minimum and maximum. So these steps I'll take an example and then demonstrate so that it will be clear. Okay, let us take one data sets here. Okay, you can see some data points there are around 15 data points are there, where I can see that small n is equal to 15, where small n indicates the sample data set size. So you can see there the data points given here, and we have already arranged, like first step towards our plotting box plot is arrange the data points. You can see there 10 to 59 data points are already arranged. If not arranged, we have to arrange it in ascending order. Next step is we are supposed to calculate the quartiles, that is Q1, Q2, Q3 and Q4. So how to calculate Q1? Let us see now. So from this given data points, we have a formula called 0.25 into n plus 1. This is a simple formula to calculate Q1. Let us apply where n is known, n is equal to 15. So as I told you, n is the number of data points present in the sample data set, and 0.25. Okay, so n plus 1 multiplied into 0.25, it gives 4. That gives the fourth position. So that means Q1 is present in the fourth position in the given sample data set. Okay, and we all know that Q1 is basically the first partition where we have 25% of the data points falls below this Q1 quartile. Okay, now you can see there fourth position from the given data points 1, 2, 3, 4. You can see there fourth position is data number 25. Data point is 25. So this is the value of your Q1. Now the value of Q1 is 25. Similarly, we have to find out Q2, Q3 and Q4. So to calculate Q2, we apply a formula called 0.50 into n plus 1, where n indicates the sample size of your data set, and that gives to 8. So this 8 is what the position of your Q2, or Q2 is also called as median. So the position of 8 in a given table is number 33. You can see the sample size number is 33. From your position 8, you can see there 1, 2, 3, 4, 5, 6, 7, 8. So in the 8th position, we can see the data point that is 33. That becomes your median or Q2. The next step is we are supposed to calculate Q3. And the formula is 0.75 into n plus 1. And that gives the position of your Q3. That is third quartile, 12. So 12th position, the number is 36. So 36 is the data point present in the position 12th position. You can see here 36 is here. So now we calculated Q1, Q2, Q3, and Q4 by default we know is nothing but the last cut or the last partition, the maximum value, that is 59. And the minimum value in this data point is 10. So now we calculated all the 5 data points, that is min, max, Q1, Q2 and Q3. So all 5 points are available. Next step is we have to plot a box plot, and then we can interpret what exactly we can draw inference from this box plot, whether the data set is skewed and are there any outliers present. That we'll see in the next slide. Okay, so this is what the values which we have got from the previous slide by calculating Q1, Q2, Q3, min and max. Now I'll show you a box plot, how to draw box plot from these 5 values. Yeah, now the first step towards plotting a box plot is, as I told you, 5 values are present. That is min, max, Q1, Q2, Q3. The next step is we have to draw a scale. Okay, we draw a scale, and this scale should be sufficient to accommodate the data points width. That is, the minimum data point is 10 and the maximum is 50. So what I'll do is I'll start from 0 here, 0, and then I take an interval of 10, like 10, 20, 30, 40, 50, 60 and 70. I'll stop at 70 so that I can cover all the data points. So 10, then 20, 30, 40, 50, 60 and 70. I'll stop at 80. So this size depends upon the scale, depends on the data point spread. Okay. And the next step here, what I'm supposed to is, now I have to pick the Q1. So what is the Q1 value? So Q1 value is 25, and this value we got from the previous slide. Okay. So Q1 25. This 20 is here, and 25 comes in the middle of this, right? So I have to mark here. I'll just mark here. This is what our Q1. Next step is we have to mark Q2, that is the median value, that is 33. And 30 is here, 33 comes somewhere here, 33. So I'll mark here, assume this is the 33. Okay. And next comes Q4. So Q1, Q2, sorry, Q3. Next comes Q3. So Q3 value is 36. So 36 is almost here, near to 40. I'll just mark here. Okay. So 3 points are marked here. Now what I'm supposed to is just extend this in such a way, vertically. Just extend that and then join this. Join this. It forms a box now, where the first point, this is what my Q1, and this is what my Q2, and this is what my Q3. So 3 values I have plotted, and next 2 values are min and max. So min value is 10, right? So 10 is here, right? And max is 59. So 59 is coming somewhere here, comes somewhere here, right? And after plotting this on the graph, just join the minimum value to the vertical line joining with our Q1. I'll just join here, and this becomes the first whisker or lower whisker. And next part is I have to join the maximum value to the vertical point that is connecting Q3. So I'll just join here. Okay, and this is what my max, and this is what my min value. Right? So this completes our plotting a box plot. But the point here is, after plotting this graph, how we can interpret our data set, our data points with respect to box plot. First point, just observe the, the median. What is the position of the median? Whether that median is exactly between Q1 and Q2. If it is mid of Q1 and Q3, then you can say our distribution is normal. Like say for example, if you observe here, if this is a box plot, this is a box, and exactly in the middle, this is Q1, this is Q2, and this is Q3. If the median is exactly cutting, okay, the box into 2 halves, Q1 and Q3, then we can say this is normal distribution. Our data set is normally distributed. Normal distribution. You can say it normal distribution. What if, for example, if the median is somewhere very close to less than, if the median is less than, okay, the actual mid position, okay, mid position less than or Q2 and very close to Q1, then it is called as left skewed. There is a skewness in our data. Left skewed. And if our median is close, more than Q1 and close to Q3, we can say more than Q2, then we can say it is right skewed. There is a skewness in your data. Right skewed. Right skewed. Like this, we can find out if there is any skewness or normal distributed in our data points. And apart from this, if you want to find out if any outliers are there, so if any data points are there beyond this max, if any data points are there beyond max, and if any data points are there less than this min, then those data points we can call it as outliers. And there is a simple formula for this to find the outliers: Q1 minus IQR, okay, Q1 minus IQR into 1.5. Okay, and this is for lower outliers. From the outer outliers, that is Q3 plus 1.5 into IQR. If any data points falls beyond this, then we can call this outlier. If any data points falls less than this, then we can call this outlier. Okay, like this is what the purpose of visualizing box plot using a technique of 5 summary data point. So with this, I conclude this, and thank you.